And I think we're good. Okay. Well, I guess good evening to everybody. I'm going to try and keep this as efficient as possible since it's fairly late in the East, and who knows, maybe if you're from California, we're keeping you from dinner. I'm not sure due to the time difference. But tonight we're going to talk about the digital traffic net. And our goal this year is to greatly expand the number of digital traffic stations so we have some redundancy. We'll talk about that in the program, as well as create redundancy within the infrastructure itself. That is having additional nodes available for backup. And for a number of reasons. Number one, we don't want people to burn out. Number two, in time of emergency, a single DTN can't operate 24 hours a day. A single digital traffic station can't operate 24 hours a day. And, the old adage, two is one and one is none. And so we're looking to expand the number of digital traffic station volunteers. I see a hand up. Let's see, that's my mouse. Okay, well, that's interesting. It shows a hand. So I guess what we'll do is I'll dig into, I'll share the screen here and bring up the slides. Let me get rid of some of this stuff here for a minute. Okay, don't show that again. And all the things offering me AI services while I present my program. Okay. Can everybody see the slides?
Yes.
Yes.
Excellent.
Yes.
Good. So again, my name is Jim Wades. I'm a board chair and emergency management director for Radio Relay International, and kind of my co-presenter here, my color commentator this evening for this evening's ball game is Jim Kutch, KY2D. Jim is the Eastern Area digital coordinator, and he's sort of also, I guess, Jim, kind of unofficially, you're kind of the leader in DTN, at least at present. Is that safe to say?
Yeah, we had some more infrastructure in Central and Western, but we are in need of some more out there. So I'm certainly informally trying to coordinate things across the country, although my most responsibility is here in Eastern Area.
Yeah. So what we're going to do tonight is we're going to kind of talk about, basically how DTN functions, the network topology. We're going to talk about access, how you access a digital traffic network. We're going to concentrate on Vera because it's readily available pretty much to most radio amateurs at low cost. We're going to talk about the advantages of digital traffic network. We'll dig a bit into the digital traffic station function, as well as the role of the DTS in time of emergency. That is, how the DTS role changes when the National Response Plan is activated. And we'll give you some technical details and insights on how you access traffic, how you upload traffic, things of this nature. It's not going to be an in-depth, technical tutorial, but there should be plenty of information here to get you started as a digital traffic station. So this is RRI training class TR001. It's designed primarily for the National Traffic System volunteers, RRI, ARRL, but the digital traffic station functions are available to people involved in MCOM as well. We'll talk a little bit about what the expectations are for the digital traffic station function. So let's talk first and foremost about, basically answer the question, what is the digital traffic network? Well, simply put, it's a modified hybrid mesh network. It's essentially a high-frequency based infrastructure in which you can add VHF to HF gateways. but fundamentally, most of the infrastructure functions in the high frequency spectrum. It is a multi-mode, so the backbone generally operates on Pactor 3 and 4, but it's accessible using Pactor 1 through 4, or it's accessible using Vera. And I think probably a fair number of the people on this course tonight are familiar with Vera because they're familiar with WinLink. And there's a lot of similarities between how the WinLink is accessed and how digital traffic network is accessed. The DTN is designed primarily for text-based messages. However, it can carry small binary files, as long as they're not too excessive. And the way in which DTN is structured, it's really designed to ensure interoperability. So if you look at the traffic system itself, or even Aries and Oxcom and similar programs, there's still a sizable, let's call it manual mode contingent. We still use voice communications, for example. We have voice nets. We use a voice in time of emergency. If you look at the Hurricane Maria situation in Puerto Rico some years back, pretty much all the traffic was handled by voice modes. So the idea and how we have digital traffic network structured is that DTN provides an infrastructure, but the digital traffic station function is essentially a liaison function that allows one to take traffic to or from manual mode nets, be it manual mode digital nets, packet radio networks, NTS or Aries voice nets, CW nets, and so on. And again, the idea is interoperability across a wide variety of modes and methods. It's simply a reality in the amateur radio service. If you were to take a sample, and I don't really have a statistical values put together for this, but I think if you were to walk into, say, 500 amateur radio stations in your surrounding counties, the odds that probably 50 or more % of those are equipped for WinLink or a digital mode is probably overly optimistic, right? There's a lot of radio amateurs that still use voice, maybe voice and CW. Maybe they do a limited amount of things like maybe FSQ or some of the other kind of fuzzy digital modes, PSK31. But in terms of a digital mode for messaging, traffic handling, etc., outside of WinLink, there's probably not a lot of representation. So again, the DTN is a digital infrastructure. It's a modified hybrid mesh network with an RF backbone located primarily in the high frequency spectrum. It will automatically forward traffic to its destination region upon upload. So it's relatively instantaneous. Again, it's primarily built around radiograms and radiogram ICS 213 messages, but you can send some binary files if necessary. And of course, the primary goal is interoperability, right? So we want to have let's say a liaison process in place where section voice nets, section CW nets, packet radio networks, and so forth can transfer traffic to the DTN and get it across country in a fairly timely fashion. And again, access is pretty straightforward and easy. Most digital traffic stations will probably end up utilizing Vera, and we'll talk about that later in the program. So that's the idea here, okay? So this this slide we use in some of our other RRI training classes. You can essentially see let's call it the NTS network topology at work here, right? What I call the inverted pyramid. So the DTN functions mostly at the region and area level. Okay, so you can have hubs at the section level. If somebody wants to go through the trouble of building or constructing one. But generally speaking, you have region hubs and you have area hubs. And of course, the forwarding process follows pretty much the network topology of NTS. You upload traffic to your region hub. It goes up to your area hub theoretically, and then it goes across to its destination area hub and back down the inverted pyramid of network layers. Likewise, traffic coming into your region, and of course, is forwarded to to the destination hub. The digital traffic station can pull the region hub, download traffic for his section or his zip codes that he's registered for, and he will receive traffic for his local net, his state or section net, whatever he's set up for. So this is kind of the idea. So the digital traffic station volunteer essentially is the liaison between the region hub and the section or local net level. And he can transfer traffic to DTN or bring it into a section for distribution. Jim, is there anything that you want to add to that general description?
Just let me go back to your comment about, although it is hierarchical, there is an area hub and so on, we don't adhere to that really strictly. You mentioned at the beginning that it was a hybrid mesh network. Certainly, there's no need, for example, for a Region 4 message going to Region 2 to go to the area hub in the Eastern and then back to Region 2. If the Region 4 hub can directly connect to the Region 2 hub, then that hub takes the shortest path and goes ahead and sends it. If for whatever reason they can't connect, they certainly can pop up to the area level and then back down. So it's not as strict as manual nets with voice and CW, where traffic going from New Jersey to California would have to go up to the second region net, to the eastern area net, to the western area net, and back to the region 6 net, and so on.
Yeah, and correct me if I'm wrong, but that's also an advantage in terms of management of throughput during propagation issues. Correct.
Correct. Yeah, you skip the steps that aren't necessary if the hubs can go direct. I'm not talking about the digital traffic stations. Digital traffic stations have to pick up their traffic at their region hub because that's where that traffic is located. But in terms of sending traffic, a digital traffic station should primarily upload to their own region, but they can upload at the area level if they can't get to their regional hub or if it's busy.
Right, yeah, it's busy, it's inoperative, or there's a propagation issue, or whatever the case might be. Yeah. So that's Jim. I guess we should maybe also mention that we do, at least in the East Coast and the Northeast, we do have some interoperability with packet radio systems as well.
Absolutely. We at two different levels. There are some hub operators who offer VHF connections. My hub has a VHF connection accessible here in the state of Maine. I mean, you have to be pretty close to get to my hub on 2 meters. And there are a few, Marcia, KW1U, she has in Massachusetts VHF 2-meter packet access to her hub. So the individual digital traffic stations can access the DTN in that method. We also, though, have incoming links from the 44 ARPANET and also from the packet traffic network. So traffic can come into the DTN that way. We don't currently send traffic out through those alternative networks, but we certainly accept traffic inward. Think of it like a traffic net. Most traffic nets will accept traffic from anyone, but they're only going to send it back out to liaison stations.
Yeah, very good. Yeah, so there's a lot of flexibility in how you can apply this, and it's really there's a basic configuration, but then you find like Charles does there in New York City and so forth with the packet network. So that's the story. Do we have any questions? I don't have view of the chat during the presentation phase, but are there any questions about how the hybrid mesh network is configured?
I was just going to say thank you for answering the question I didn't ask yet, which was if a region hub like W2QS is having antenna problems, it's okay to for the digital relay station, I'm sorry, the digital traffic station, to send outgoing traffic to the eastern area, if that's the only way to
Absolutely. That's absolutely the case. You can, using your example, if you can't get to your Region 2 hub, you can send it to my Eastern Area hub. Technically, you can send it to any hub, but when you do that, it creates additional records in the other hubs and so on that we don't really need to do. So try first, if you can't get to your region hub, go to your area hub for outgoing traffic anytime.
Okay, thank you.
I'm wondering what hardware we would need. It sounds like we would have to have a separate radio and a computer running all the time. And I'm wondering if you can hook up 2 radios to 1 antenna. Not sure if you can do that.
And your first comment is not true. As if you're a hub operator, yes, you want your hub to operate 24 hours a day and so on. But let's talk about a digital traffic station. And in the same way that if you're working voice or CW, you're not on the net all the time. You go log into the net, is there any traffic from me, and then take it. You do the same thing. So if you are a digital traffic station, let's say in Region 1, you would, when it's convenient for you, you would connect to the Region 1 hub via digital RF. And if there were any messages for your area of the first region, those messages would automatically be downloaded to your computer. And then you disconnect. The rest of the day, you can use your station and your antenna for anything else you want to do. In fact, you probably need to do that because unless you're going to personally deliver all the messages you pick up, you probably want to then forward them on to a statewide voice net or CW net. A digital traffic station is a liaison function. Just like going to Region 1 or going to the area net, you're picking up traffic for your area. And of course you can deliver it, but you probably will take it to a voice or CW net.
Yeah, I think that's an important distinction. The hubs are an infrastructure function. They operate 24/7. They utilize different software, etc. Whereas a digital traffic station is exactly that. It's a liaison. So as we'll allude to earlier, or later, I should say, in the presentation, the traffic system has 2 configurations, one of which is routine and the other of which is emergency. We'll touch on the latter aspect later. But you can connect once or twice a day, maybe before your section nets are meeting. Download the traffic for your section, and then you can distribute it on your section net or list it on the various nets. Likewise, after the net session, you may be holding traffic for outside your area. You can connect again, upload the traffic to the infrastructure side of the system, and then it will be forwarded to its destination. Does that help explain it?
Yeah, so it sounds like you would just need what you already have if you do Vara WinLink, but
That's
there must
correct.
be some
That's
software
correct.
change. Yeah,
Uh,
some software change to make you a node.
Yes, so they're two separate functions. To be a DTS, you just need basically the same thing you use for WinLink. We're going to cover that later in the training. For a hub operator, and Jim, you're the expert on this, but you need a BPQ 32 software package. It's a much different arrangement.
Yeah, I'm assuming you're asking what you need to be a digital traffic station. I mean, to be a hub, I'd be happy to talk to anybody who has an interest in being a hub operator, but just to be a digital traffic station, which is what we need a lot more of, your WinLink that you have already, WinLink Express, and your Vara is all you need. It's just a question then of changing how you address messages, and instead of connecting to a WinLink CMS to upload your messages, you connect to a digital traffic network hub.
Yes, and I think you need to add maybe, Jim, that there is a whitelist process to that.
Only to receive messages. The
Correct.
DTN will accept uploaded messages from anyone. If they're addressed properly, all the DTN nodes will accept outgoing messages. In order for you to receive messages, you have to be registered and set up so that the hub knows what part of the area you are responsible for.
Yes, which I guess we should at this point mention that that's fundamentally predicated on zip code, right? So
Or entire states.
or an entire state, yeah.
Like in the case of Maine, if you're a digital traffic operator in Maine, and we don't have very many of them, you basically cover the whole state. You connect to the regional hub and you pick up anything for the state of Maine, and then you're responsible to deliver it after that. Again, think of a person in Maine checking into the Region 1 voice net, and they say, I'm the Maine rep today. So any traffic going to Maine goes to that station. Same thing happens when you connect to the regional hub and you're in Maine, you get all of the Maine traffic. It's first come, first serve. If 3 Maine digital traffic stations connect, the first one to connect gets all the traffic that happens to be in the queue. Now, in large states like New York, we do break it up by zip code. It's unreasonable to have a station pick up the traffic for the entire state. So New York is basically divided into thirds, roughly: Western New York, Central New York, Eastern New York, and then the Long Island, New York City is a fourth area. So that traffic is divided and routed by zip code.
Okay. Yeah, we'll talk a little bit more about how you connect and the process. It's quite easy if you've utilized WinLink, you can do this just as readily. It's pretty straightforward. Any other questions on the process of the network topology and the DTS function so far?
Does do APRS like NTS gate messages get routed the same way into these hubs?
APRS, is that what you asked? I'm sorry.
Yeah, but like NTS gate, the system in APRS to send radiograms, do those route into the hubs the same way?
No, Jim, I'll let
No,
you answer that.
I don't know of an automatic path for those to get into the digital traffic system. Perhaps somebody has a bridge set up somewhere, but I'm not aware of it.
That's one of those things, like a friend of mine used to say about Linux and Unix. It'll do anything you want so long as you write the software.
Yeah,
It's
yeah.
probably just a matter of writing a piece of code, getting it
Right.
to move,
Yeah, and APRS is kind of an interesting animal anyway for messaging. It has some reliability issues, so you have to be a little careful with APRS versus, say, traditional packet radio or something like that. But nobody's done that yet. Let's just leave it at that.
So I have a nerd question.
Yeah.
The okay, so you have the main node stations like the Region 2 station, and people are connecting to it and stuff like that. This sounds kind of like the old internet map file system. I mean, is there like a master table of that, routes some of this stuff so that they know where they go, or does the person running the node just have to kind of know how to program it?
The node operators, again, the addressing is zip at state.
Right.
So then there's further oddities for international, which we'll leave aside for the moment. So my hub, for example, knows how to route each state. So I have routing rules of what to do with Maine, with California, with Oregon, and so on. So all 50 states, all provinces of Canada, and international have routing rules. The end users just have to stick it in a hub. And the other nerdy thing is the hubs are smart enough to know how to route around or take alternate paths. If I can't get all the way to California in one hop, I will send the California traffic as far as Wisconsin and let the Wisconsin hub worry about it.
Yeah, that reminds me of, as they called it, the bang path days in Unix and like the early internet. That's exactly how it worked. You had lists of stuff, and it's like, okay, I can't reach that guy. Well, then that's your problem. You find how to get there. So sometimes you'd get a message that would be in 3 jumps, and then the next one you'd get would have taken 25 just to get between 2 cities or something.
Yeah, we don't see much more than 5 hops to cover everything. It's incredibly, unless it's international, it's incredibly rare to see. Again, this is on HF, and the hub operators are very diligent about watching what's going on.
Yeah, cool. All right, so that was my curiosity anyway. Thanks.
Yeah. Very good. No, that's a good question. And I suppose the quick answer to your question would have been yes. It's basically like routing tables, But anyway, so let's move on a little bit. So let's talk, and we can take more questions at the end of the presentation. So essentially, the digital traffic station function, we'll kind of dig into that. So, we've kind of covered it. The DTS's job is to, in most cases anyway, is to transfer message traffic, that is radiograms or radiogram ICS 213 messages between local and section traffic nets and the digital traffic network. The idea, again, is full interoperability. In the real world, even in, say, law enforcement and emergency services, there's a variety of methods. There's voice talk groups, there's mobile data terminals, there's other forms of messaging available. And messages sometimes do move between modes and methods to reach, the addressee, you might say. So the idea here is a radiogram should be able to pass through DTN, that's at the infrastructure level, through the network, and then through the DTS function, it can be transferred to a CW traffic net, a voice net, whatever the case might be. The idea that we're looking at here is that a couple of things. We don't want to leave a daily schedule unguarded, to use an old-fashioned term. So essentially, we want to have sufficient DTS that, let's say, for example, there's 3 or 4 DTS in a section, and maybe in the ideal world, they would maybe put together a little duty roster. They would, if one of them couldn't make his schedule to download traffic for that particular state or section on a particular day, he could drop an email or a phone call or a text to one of the other DTS and say, "Hey, I'm not available today. I've got a doctor's appointment or I had a family emergency. Can you cover the DTS function?" So ideally, what we would see is that perhaps there's 3 or 4 DTS in a state, and the digital traffic stations communicate with each other. They go through the process of essentially constructing a little bit of a formal or informal duty roster. Hey, I'll do Monday, Wednesday, and Friday night if you do Tuesday and Thursday, and so-and-so will do Saturday and Sunday, whatever the case might be. And then, of course, if there's a situation where somebody can't do their perform their duty on a particular night that he's scheduled for, there's some intra-section communications to fill that gap. So we always have daily routine liaison between DTN and the section and local traffic nets. The other idea, or the other requirement here, is that, as I alluded to earlier, there are two configurations for the traffic system. If you've attended some of our other training classes, such as designing an emergency communications exercise, you can learn a little bit about the National Response Plan. But essentially, the National Response Plan defines two configurations for the traffic system, one of which is our routine day-to-day configuration, right? Traffic percolates up through the network and then back down at the destination. The nets meet in a certain, let's call it a time domain topology through scheduled, scheduled times and layers, and it's not particularly designed for speed, and it is therefore very difficult to prioritize the flow of message traffic. DTN eliminates many of those problems, and so under the National Response Plan, let's say we have a major disaster somewhere, and there's large amounts of, say, for example, health and welfare traffic being originated. We may go ahead and issue a directive basically saying, okay, the National Response Plan's been activated. We would like DTS volunteers to connect every hour and download, incoming traffic for their section on an hourly basis, or maybe every 2 hours or every half hour if there's priority traffic or something of that nature. And again, this would be it'd be unrealistic, for example, to have one DTS in a section doing that, say 12, 16 hours a day or 24 hours a day. So the goal would be that nobody burns out. You share a few nights out of the week as opposed to doing 7 nights a week till you've had enough under routine conditions. But under emergency communications conditions, you might say, hey, look, I'll take even hours, you take odd hours, or I'll perform the liaison function from 6 a.m. to noon, you do noon to 6, et cetera, et cetera. So the idea would be that if the National Response Plan is activated and we issue a directive that says, hey, we would like digital traffic stations to connect, every hour or whatever to the DTN, download incoming traffic for their state or section, we can go ahead and do that. Or if there's some reason that there's large quantities of traffic moving between, say, 2 states, and only 2 states, we might just activate digital traffic stations and other volunteers to handle traffic between those 2 states. So we would like to have the ability to, essentially share emergency communications duties within this liaison process. So the way the National Response Plan is written is that if an activation request message is originated to activate the plan, those that are active on nets submit an operational readiness message, and this goes to a network manager who goes through a certain process of determining based on these operational readiness messages, of what type of traffic is going to be originated, what nets are activated, what agencies and areas groups with which the operator has liaison. All of this is kind of collected as data, and then a determination is made as to how often we would conduct the connect download frequency for, say a region, a section, or multiple states, right? So the idea here is that we would, somebody, responsible for the emergency communications management process would say we would like DTS to increase their download and connect frequency, and then it would be up to the DTS operators within a state or section to communicate amongst each other, and then kind of put together a duty roster or a process for sharing that duty throughout the activation process, right? And this would run in parallel to other response functions that are defined in the National Response Plan, like the priority entry point process, the watch frequencies, things of this nature. We have a separate course on that covers this, so I'm not going to dig deep into it. But I think this probably adequately explains the fact that if we're going to be serious about being able to support a truly significant disaster operation, we need to have more than one person per state or section.
Can you send a link to that course in the follow-up material?
Yeah, I can do that. Yeah. As a matter of fact, I can share these slides, and they'll be posted to the RRI webpage. And if you go to the RRI webpage, you can see a copy of the National Response Plan. You can download it. It's available in both English and Spanish. You can also go to the RRI YouTube channel, and you can find a course on emergency communications planning and emergency exercise design and different peer-reviewed training classes that are available pretty much to anybody. But I don't want to go too deep down that rabbit hole here because we have a limited amount of time. But it will fill in some blanks maybe in terms of what the overall emergency response process would be for the traffic system.
Great, thank you.
DTS qualifications. So obviously, ideally, the digital traffic station has some demonstrated traffic handling experience. He's familiar with the radiogram. The radiogram structure is intuitive. He understands handling instructions and date time group, and when the radio day starts at 0001 Zulu, he knows how to properly transmit a radiogram on a voice net, for example. He understands how to send a service message. The fundamental traffic handling skills are required. We also would like digital traffic stations to go through the RRI certified radio operator training process. So we have a repeating cycle of training programs. We're kind of in the midst of one right now. You can find the training schedule on the RRI webpage. But the idea behind the certified radio operator process is that you've attended the emergency communications planning course, and you've attended this digital traffic station training course, and you've attended the course with an introduction to the traffic system and so on. So you understand the management philosophies and the mechanics of how things work. And of course, you get a really nice certificate that shows that you went through the training and vetting process. DTS should obviously agree to follow, the RRI, ARRL standards. They're essentially one and the same, particularly with the recent signing of the Memorandum of Agreement between RRI and the League. But, generally agree to follow the traffic system standards for, the proper origination, relay, and delivery of traffic. This is the methods and practices guidelines and things of this nature. And perhaps just as importantly, if not more so, is just the willingness to do the job, right? The willingness to regularly check the assigned mailbox, opera or region hub in advance of your nets, distribute the traffic, be that liaison between local and section nets and the DTN. And obviously, as has always been the case with the ARRL and also RRI is to send a monthly digital activity report to the area digital manager or digital coordinator, Jim, for example, KY2D in the East Coast. Jim, do you want to add anything to these qualifications?
No, I will just say, as you see frequently in resumes, you listed a scary set of requirements there. It's or equivalent life experience, as we say in resumes. Certainly, if you're a seasoned traffic handler and know a lot of that stuff, that counts. To be a certified radio operator, yeah, there's higher standards, but to be a digital traffic station, it's although we'd like the digital traffic stations all to be certified radio operators, you don't have to be, we need more digital traffic stations.
Right, exactly. Yeah, it's not a prerequisite. The certified radio operator training is not a prerequisite, but we would like you to eventually get it, just so that you understand that, oh, a national response plan exists. Oh, this is the concept of how we respond to an emergency. Here's the philosophy of how things are supposed to work, essentially. But the real thing here is you just need to be a reasonably experienced traffic handler. You don't have to be an expert necessarily, but you need to be able to competently, relay, originate, receive message traffic. You have a willingness to essentially, do the job on reliably and report as necessary, and just basically, agree to follow any RRI or ARRL standards that arise.
And a real commitment to a service mentality. We are serving other fellow amateurs, we're serving the public, we're serving served agencies, and we can't pick up a message on Tuesday and not bother to do anything with it until Sunday. That just reflects very poorly on the entire system. So a commitment that if you're going to do this, you're going to do it right is extremely important.
Yeah, I think, one of the goals that when we formed RRI in 2016, the goal was to modernize, enhance, and promote the traffic system. And the philosophy was always that, we wanted quiet professionals, not professionals in the sense that you're paid, but, we want to have a quality program that therefore attracts quality people, right? So we do want people to take pride in it and do it out of a sense of altruism. I guess like Elizabeth Barrett Browning said, the sweetest lives are those to duty wed, whose deeds both great and small are close-knit strands of an unbroken thread where love ennobles all and all that kind of stuff. But, seriously though, do it out of a sense of wanting to improve the amateur radio service, wanting to make the amateur radio service relevant, wanting to leverage the benefits of public contact and public outreach. These are all things that we want to achieve. Raise the profile of the amateur radio service through service and quality. Sorry about that. And telegraph sounder going in the background. Let's talk a little bit about the area digital manager and area digital coordinator. Basically, the area digital coordinator, he's responsible for ensuring that the operational and technical problems that might arise are solved. And therefore, he's responsible for ensuring system readiness. So he's kind of the technical guru. He's the guy that keeps in touch with the digital traffic stations and the hub operators in his area. He maintains regular communications just to make sure the system is always, always in a good operational status. He coordinates with the RRI Emergency Management Director or his designee to ensure operational readiness under the National Response Plan. He provides advice and input to both RRI and NTS area staff and the RRI Board of Directors. And he provides training and assistance to hub operators and DTS as needed, helps them get started, answers their technical or operational questions, provides that assistance as they get started in the process. He's kind of the go-to guy for his respective area. Jim, you hold that position. Is there anything that you would like to add to that?
No, it sounds good.
Okay. Let's talk a little bit about the role of NTS section staff. Let's be honest. You can build a wonderful infrastructure, but the rubber meets the road at the local and section net level, right? And so the ARRL section staff, the section net managers, the section traffic managers, they have an important role to play in building an effective and professional quality traffic system. So, at least from our perspective anyway, one of the roles of section staff is to recruit and retain not just traffic handlers, but also digital traffic station volunteers as needed. I think there's a tendency sometimes for section traffic managers and section managers to concentrate on collecting the monthly reports, and we tend to overlook the importance of visibility, traffic handler recruitment, getting people involved in these functions and giving them a sense of purpose, right? So recruiting and recruiting and retention is important. Ideally, section staff will familiarize ARES and other MCOM groups with the capabilities of the traffic system and digital traffic network, and likewise on occasion integrate NTS assets, including the digital traffic network, into local or section emergency exercises. Help us by ensuring that the DTS volunteers in the section are coordinating amongst each other to ensure reliable daily liaison under routine conditions. We would like all digital traffic stations to register with RRI so that you can receive any kind of operational bulletins that might be issued in time of emergency. There's no cost. We don't charge dues or any of that stuff. You simply have to register as a radio operator, and then you get the emails. You get operational bulletins during a hurricane or an earthquake or something of that nature. And then, of course, we want to integrate the peer-reviewed training that RRI and the ARRL have put together into the NTS program to ensure that new volunteers really understand the overall system functions. They understand the purpose of HXC, right? They know what the new HXA handling instruction means. They understand the definitions of message prioritization and so forth. So, we need people who are trained, and a lot of that training really starts at the section level. So this is kind of the role of the section staff. We can't do it at a distance from RRI. I don't think the league can do it at a distance from Newington. It's up to the section manager and his team to do the recruiting, to raise the visibility of these programs, to ensure that all the functions of NTS, including DTS functions, are operating correctly. And as the goal is to find the right people and ensure operational readiness and ensure that a communications process is in place. So that's the general philosophy. So let's kind of go on now and talk about connecting to the digital traffic net. And tonight we're going to concentrate on utilizing VERA. And the main reason being is it's inexpensive. You pay a one-time fee for a license, and then you can use it, and it performs very well. It's got excellent throughput, even under poor signal-to-noise ratio conditions, and it's you don't need a specialized modem. You don't need an expensive backdoor modem or government level data modem to connect. So, why Vera? Well, obviously it's reasonably robust. It tolerates poor signal-to-noise ratios. You don't require the expensive modem. It's a sound card interface process. All you need is either a more modern transceiver like an ICS or an IC 7300, or a somewhat older transceiver with a signal link or similar type of sound card device. Again, no significant financial outlay, and under good conditions, Vera can rival Pactor 3. It's easily downloaded off the internet, and many radio amateurs that are already involved in digital communications are already set up for WinLink, so they already have Vera, and they already have the WinLink program, so they can access the digital traffic net very easily. The WinLink development team did a bunch of studies on the performance of Vera, and depending on the study, what you'll find is that it performs quite well. Again, in some cases, it performs nearly as well as Pactor 3 under high-frequency conditions, particularly as you get down into the poor signal-to-noise ratio level. So if you take a look at this, for example, you can see the Vera performance is the orange line under a simulated multipath condition, and it really performs surprisingly well. So in terms of, say, the cost-benefit analysis, Vera is a bargain. It performs quite well at minimal cost. It's easily downloaded. Not a lot of effort involved in getting it up and running. It's definitely been a boon to amateur radio digital communications, I think. Jim, did you have anything you wanted to add about Vera and its value proposition?
The free version is certainly adequate for the casual or low volume digital traffic station. If you're going to do this very often, or you're in an area where you have high volumes, you want to get the paid version. But the paid version cost is, last I looked, was $70, so it's not a huge expense. The only other comment I'll make is if you're not into this at all, WinLink or VARA, but you do run FT8 or FT4 or any of the WXJTX, you have all the hardware and all the rig connections. All you're going to need to add to be a digital traffic station is software.
Yeah. And you don't need a lot of computing power for it either. You use an older computer and you're good to go. So I think probably 90% of, what would you say, Jim? Probably 90% of our DTS use Vera.
Yeah, certainly any of the recent ones. Back in the day, you had to have Pactor, but once VARA came out, anybody joining as a digital traffic station. And I find that as a hub operator, sometimes I can connect to other hubs better with Pactor and sometimes better with VARA, depending on band conditions. So the hub stations, for the most part, operate both, so you can connect with either one.
Right, yeah. So another nice thing about Vera is it's designed to be integrated into WinLink Express. And WinLink Express is the program that you will end up using for the DTS function. Vera is really a custom made for this in many respects. The WinLink Express can be downloaded online, and you don't have to have a WinLink email account to utilize WinLink Express on DTN. You simply have to be whitelisted so you can download traffic for your section or your portion of your NTS section. again, all you have to really do is download WinLink Express and Vera, and you're pretty much good to go. And and there's probably radio amateurs in your local radio club or Aries group that can help you out if you have questions, further questions about it, because a lot of Aries and MCOM types are already active on WinLink, and it's essentially the same process. So the software is straightforward. As mentioned earlier, you don't use the computer sound card interface. Instead, you utilize a simple USB sound card interface like a Signal Link, or again, some of the newer transceivers like the ICOM IC7300 have that already built in. I myself,
or just a sound fob. I'm running the hub on a $12 sound fob from Amazon.
Yeah,
it's not a Signal Link or anything like that. While I've got the microphone, just a quick comment. It's important to understand that we're using WinLink Express, the client software, to access the digital traffic network, and we're not using the WinLink network. So it's sort of like using Outlook on your PC, but not accessing Microsoft Mail, accessing Google Mail or Yahoo Mail. So we're doing the same thing, and we need to make sure that we don't get those two tangled, because WinLink addresses have one format and digital traffic network addresses have a totally different format.
Right. Yeah, absolutely. Yeah. Remember that you're just using the software. Now you can use it for both. You can use it for WinLink, you can use it for digital traffic network, but you're really using it, the software, on two different systems. Yeah, exactly. So that's the story. So in much the same manner as you set up any, say, digital communication system on your, with your transceiver, you have a process for setting up the proper input levels and transmit delays and things of this nature. It's pretty straightforward. Generally, once you have that set, you adjust your audio input level to where you hit just about the knee of the curve at which the power output level begins to level off, and AGC is minimally initiated, and then obviously make sure that your transceivers properly connected to a low impedance ground, so you'll get RF on the audio and control cables. And with Vera, you should be able to transmit a really nice, clean signal if you follow those basic rules. There's not much to it. And again, any radio amateur in your local club who does PSK 31 or FSQ or some other digital mode can walk you through that process, because it's pretty much universal for all digital communications processes with a high frequency transceiver. So a setup, again, is something it's kind of becoming common knowledge in the amateur radio service. The frequencies that digital traffic network uses are kind of spread throughout the common amateur bands, 80, 40, 30 meters, 20 meters, 17 meters, 15 meters. So for example, if you take a look at the KW1U hub, you can see here frequencies down here at the bottom of the slide. And so the MBO scans these frequencies and listens for either a Pacto or Vera call. Each frequency is monitored for approximately 3 seconds in the sequence. If a call coming in is detected, the mailbox stays on the frequency. Communications is established, and it's retained until the traffic is downloaded or uploaded. And then once that QSO, you might say, is complete, then the scanning resumes. So again, this is very similar to what happens with WinLink, right? WinLink nodes are function in a very similar manner. Jim, do you have anything you want to add to this?
Just that keyboard connections to the hub is discouraged. We really want an automated connection. That's why we're using WinLink Express. We want a digital traffic station to connect to the hub, quickly transfer all outgoing traffic, and quickly receive all incoming traffic, and then disconnect. If somebody connects to a hub in keyboard mode and starts typing commands looking for traffic, they tie up the hub for an undue period of time.
Yes, I think that's. I thank you for bringing that up. Yeah, if you take a look at WinLink Express, you can go ahead and prepare all of your outgoing traffic, post it to the outbox, and then when you connect, it will automatically be transferred to the hub. So make sure you do it that way. That's the best process. It's just like sending an email, right? You compose your email, and then when you're ready, you hit send. I mean, that's essentially it in a nutshell. Frequencies. It's typically transceiver is operated in the upper sideband mode. Vera is a rather, let's put it this way, it uses a somewhat complex modulation scheme. So you want a bandwidth setting of typically about 2.8 kilohertz or a little wider. And that will provide better throughput. And remember that the reference frequency may be different than your actual frequency. So, for example, the center frequency for Vera will be about 1.5 kilohertz higher, right, than the dial frequency. Okay, so understand that there can be a difference. WinLink Express, interestingly, does this for you. You enter in the reference frequency, and it'll tell you what the dial frequency is. But understand there is a difference there. Now, you're not using WinLink, but you could probably go ahead and put the frequency in there and get the same result. Correct, Jim?
Yeah. The point really here is that the frequencies that are stated in any DTN document is a dial frequency. And depending on what software you're using, there's been a lot of discussion right now going on the chat about PAT and so on. Some of these software packages ask you to enter a center frequency, but just note that if you're using software that requires that, these frequencies are dial frequencies that are specified, like the ones you just showed for the KW1U hub.
Yeah. So again, if you have questions, you can call Jim, KY2D.
Right.
Anyway, so.
No, serious on that note, I'd be happy to answer questions. If there's 60 people on this call, if I get buried in the next day or two with calls, understand it might take me a while to get back to you, but you can certainly send me email.
Yeah.
Jim at ky2d.com.
Yeah. So we'll maybe share that in the chat, Jim, when you have an opportunity. So receiving messages. So again, essentially what we do is we use WinLink Express. We call our assigned, region hub, the MBO. You can select the appropriate frequency for the time of day. So, for example, I might use 80 meters at night. I might use 40 meters in the daytime. If 40 meters is really noisy, maybe I'll try 30 in midday, early afternoon when there's a lot of solar absorption. So you can select one of the scanning frequencies and establish communications. If there's messages queued for your station, they will be transferred to WinLink Express, i.e. your PC, and then as soon as they're downloaded, they will be marked for deletion by the mailbox. So something important to remember here, and I'll have Jim, kind of expound on this a bit. But if you use the same WinLink Express program to connect to both DTN and WinLink, make sure you don't have outgoing traffic in your outbox. In other words, the radiogram traffic can't be sitting in your outbox when you connect to WinLink. So connect to DTN, clear out your that outgoing radiogram ICS 213 traffic out of your outbox. And then when your outbox is empty of that traffic, then you can use the same program to connect to WinLink if you have a WinLink account, and you won't have to worry about the confusion and the rejected messages that Jim mentioned earlier, which is if you have radiograms sitting in the outbox in WinLink Express and you connect to WinLink, they're going to assume that they're addressed to somebody on the internet, and they're going to send them off into the internet, and they're going to bounce around out there and be rejected ultimately, so the traffic won't go anywhere. And so understand that. Jim, is there anything you want to add to that?
No, you pretty much covered it. It's just, you can't put a Federal Express shipping label on a box and drop it in a UPS drop box. And that's essentially what we're saying. You can't address a DTN message using the DTN addressing style and load it into a WinLink network server.
Right. Yeah.
Somebody on the. A lot of people are pushing chat back and forth here, and I'm monitoring that at the same time. The essence basically is, as was just said in the chat, is we're using WinLink just as the client software package. We need to distinguish WinLink, the client software, WinLink Express, from WinLink, the server network of CMS, common message servers. So you can't put a DTN message into a WinLink CMS because the addressing's wrong.
Yeah, that's a good clarification. Yeah, absolutely. So I think we beat that dead horse now. So let's move on to addressing. So if you're like me, old enough to remember packet radio, when we had a fairly extensive packet radio network and forwarding systems, the process is very similar, right? So the outgoing radiograms are addressed to essentially NTS and :zip at NTS dot whatever, for example.
No dot.
Oh, I'm sorry, you're right. NTS.
It's NTS : zip at NTSXX, where XX is the two-letter state or Canadian province code.
Right, I'm sorry, Jim. Yeah.
So you would get to me as NTS : 04543 at NTS-ME, since ME is main.
Yeah, there's a couple of examples here that I put in the slides. And I apologize for the misstatement. I'm kind of tired. It's been a long day. I started teaching a class this morning at 7:45, and I've been going ever since. But
I pointed out only because as a hub operator, all the other hub operators can attest to this too. We get messages when an improperly addressed message comes through, and at least a couple or three times a week, I go in when I see a message, when I get one of those alerts, and I have to correct somebody's typing. They put an extra dot in there, they put a hyphen in there, they didn't put a colon in, they said NTS with a zip without the colon, and so on. So the hub operators do correct these things, but it's extra work for us.
Yeah. Understand that computers aren't like people who's he left out a colon, no big deal, like on a CW net or a voice net. But yeah, you can see two examples here. NTS : figures 49107 at NTS MI for Michigan, or the other one here, NTS MA for Massachusetts. International messages are a bit different. So, for example, if you wanted to send a service message to DL4FN in Germany, the address would be, NTS colon Delta Lima 4 Foxtrot November at hyphen DEU Delta Echo Uniform for Deutschland for Germany, and so there is some information in the field operations guide and so forth on how to address international messages here. But again, you can see the example here that I put in the slide. The reason it has to be a call sign is you can send a radiogram to a radio amateur, but you can't necessarily always send one to a third party based on what the international agreement is. So that's why it has a call sign rather than, for example, a postal code or something generic. Okay, so something important to remember. In the subject line, you will want to specify essentially the destination for the traffic, right? This is more for the human interface. City followed by a call sign, city followed by a zip code, or a city followed by an area code and prefix. So for example, Detroit, 313878, for downtown Detroit. And of course, if you don't have a phone, you could say just New York. But the idea is to give the digital traffic station an idea, the downloading or receiving digital traffic station, an idea of where the traffic is for. So you can see that at a glance in his inbox when he goes to list traffic for his section net. So as far as the actual radiogram itself, you simply type it out like you would a normal radiogram, right? All caps, the network management data, the header, then the address lines, the break, the text. Ideally do, 5 or 10 words to a line, so it makes it easy for the traffic operator to take it to a voice or CW net. But remember that each radiogram is essentially treated like a separate email message, right? So each radiogram has a separate subject line, a separate address, separate subject line, and then the radiogram is in the text of the outgoing, let's call it email. It's not email, but the outgoing message window in WinLink Express. Jim, any nuances to add to that?
Yeah, basically what Jim is saying is we don't do book messages within the DTN. Each message is its own unique entity. Also, pay attention to the fact that these messages are very likely to end up on a voice or CW net later. And a somewhat common occurrence is folks will put illegal characters inside the body of the message. So again, it's just like sending on CW or anything else. The only punctuation that is allowed within a message is a slash, X-ray for a period, comma is spelled out, exclamation point is spelled out, and so on. You see this a lot in addresses. People will just start typing and they'll say Jim at ky2d.com. But in a radiogram, it's Jim @ ky2d.com. And so it's a lot more words, and that's important to do when you fill this out. Question mark has to be spelled out too, as somebody just pointed out in the chat.
Yeah, query, Q-U-E-R-Y.
Right.
So again, your goal here when uploading or sending traffic is to make the process as easy as possible for the DTS who has to download the traffic, then take it to various nets within his section, right? So you want to make his workload or her workload easier too, by ensuring the messages are properly formatted, the check is correct, et cetera, et cetera. There's no illegal punctuation and the like. it should be mentioned also that WinLink Express, again, it's pretty much just like originating emails. It's really super easy. The text is basically just the radiogram. So, I guess if we want to drive any points home here, obviously we need more digital traffic stations, not just for routine day-to-day network operations to ensure that radiograms are moving smoothly, quickly, and efficiently to their last mile of point of relay and delivery. But we also want to ensure that we can support an emergency communications function if called upon to do so. The beauty of DTN is it's pretty simple and straightforward once you understand it. There's no great mystery involved. The addressing scheme is very similar to the older packet radio protocols. WinLink Express is very similar to common email programs like Outlook. DTN's important. It carries fairly high volumes of message traffic every month. Jim, what's a typical monthly volume this time of year for the eastern area?
About 7,000 messages, 8,000, somewhere in that range. The high traffic. I just pulled together the statistics for the whole year, and our big month was 10,000 messages.
Yeah. And that's for the eastern area, right?
Correct.
So,
That is the aggregate responsibility of 77 stations. Between the hubs and individual digital traffic stations in eastern area, we have 77 individuals who report their statistics, and the high month was 10,000.
Right. Yeah, so DTN's important, and it'll become increasingly important as we move forward into the future of amateur radio. I personally hope there will always be snappy CW traffic circuits, and I like voice communications. I like a well-run, efficient, single sideband net. But DTN is going to be increasingly important, particularly as we've over the last maybe 7 or 8 years, we've made great progress developing programs and working with MCOM organizations and so forth. And there's going to be a lot more interaction between local MCOM, ARRL sections, and NTS. Based on a lot of the work that we've done over the last maybe 6 or 7 years, so you will perhaps see DTN playing a role in a future significant disaster of some kind. So please consider volunteering. We don't want maybe 1 or 2 guys in a section to have to do all the work, and hopefully this presentation has given everybody a bit of a balanced insight into what's involved. And we're here to help you get up and running and get involved in the process. So some links, obviously, visit the radiorelay.org webpage. You'll find a publications section and a lot of very useful information on the website. I guess beginning in 2022, the ARRL finally started really looking at how to improve NTS, and we're working together with them to move forward and reinvigorate traffic handling and make it viable and effective and modern. So drop in and see the NTS2 website at the ARRL. And then, of course, if you want to dig into the National Response Plan, in either English or Spanish, those are available on our publications page, along with a whole bunch of other information. So again,
Jim, somebody just asked if the slide deck will be available, and I believe you said earlier you're going to post it on the RRI website, correct?
Yes, that's correct. Yeah, it'll be available, and this recording will be available if you go to YouTube and you search Radio Relay International. You'll see a fair number of training videos there that you can dig through, and this will be posted there probably tomorrow or Saturday. So within 24 or 48 hours, this will be on, tonight's session will be on YouTube. So I will stop the share, and I guess, Jim, was there anything in the chat we need to
somebody, they were flipping by here fast, but somebody said, so does a digital traffic station pick up messages and then put them on a CW net? And the answer is yes. You can, once you've picked up a message, it's your responsibility. You can do three things with it. You can deliver it, you can forward it on to somebody else on a voice or CW net, or you have to service it back to the originator. But it's yours once you pick it up off the digital traffic network. Yeah. Nothing else came up that I'm very excited to see. There's a lot of expertise in this call. A lot of the questions that might have come to you, Jim, or to me are being answered by other participants in the call. So that's great. We've got a lot of very active digital traffic stations in the audience here tonight. We tried to limit this to an hour and a half, but we got about another 7 or 8 minutes. Are there any questions that I can answer or Jim can answer? And again, if anybody wants to reach out to me, it's jim@ky2d.com for tomorrow or later.
So I looked up some stuff on the question of APRS to WinLink or APRS to the HF side, and it can be done. There's a couple of software packages out there. The problem is you have to make sure you set the filtration right, because you don't want the APRS acknowledgement packets going out on HF.
Right.
So and it's probably a big enough problem since they mentioned it that people have been doing it. So, you know.
Yeah. One of the other members of the group here tonight said that they're doing this in Massachusetts. So there is some evidence that it is being done.
Yeah.
I'm just not aware of it.
Yeah, and I'm kind of a head scratcher. I mean, I don't know. I haven't looked at that software, but it's like, you know, how do you encapsulate the, you know, the message? I guess the APRS gateway just knows that if it sees it, it hands it off rather than tries to interpret it, I guess, you know, so.
Yeah, and you do kind of run into the issue of vetting, right? Obviously, anybody can originate a message, but, you know, we want to. It's nice to have a process where you have experienced traffic handlers understanding the rules of message composition and so forth. But I guess anything can be done if you put your mind to it, right?
Yeah. Well, you know, I was going to say, you know, write, you know, fire up Direwolf or something and write something to steal the packet and rewrite it, but, you know, oh well.
Yeah. So, and any other questions, comments? Rotten
Yeah,
Tomatoes?
hand up. Yeah, Jim, I got a question.
Yeah.
Yeah, is there a current list of DTN nodes, modes, and frequencies? I've seen various lists in like the Q&I and other emails back and forth, but is there a current up-to-date list?
Not currently, no. The hub operators are getting together soon, and we hope to update that. There's been some changes across the country. The Region 8 hub changed recently. The Region 2 hub changed recently. There's been changes out in Western. So depending on, I can give you some of it depending on where you are. If you want to send me a note, can certainly share the information for Eastern. I don't have all the information for Central or Western.
Yeah, I've got some of it. Like I said, it was in a nice article in Q&I and other. There was a website. I forgot the exact name. DTN dash
NTS dash digital.
Yeah.
NTS dash digital. It's a little out of date, and we are working on bringing it up to date.
Right. Okay. Good.
So I'm out in the Western area. I am actually part of the voice network for Region 7. We don't have a section net for Western Washington or Eastern Washington. It all kind of gets rolled into the Region 7 daily traffic net. So I know we have one digital station who happens to be the section traffic manager for Western Washington. I don't know what else is out here? How do I find more information?
The individual you're talking about is running the hub for Region 7. And
Correct.
I don't know what digital traffic stations he has. I hope to find that out. As I said, we're planning a hub operators meeting for the whole across the country here later this month.
Because frequently what happens is George grabs the messages off of the hub and brings them to Region 7, and we some days we don't have any, and other days we get 20. So,
And that could depend on how often he goes to the hub and picks them up. It could also depend on how the traffic flows into the hub. If there were more stations out there, the hub operator, could break it out by state or break it out by zip code ranges and distribute it down a little more finely than just having everything go to one operator.
Right. And we've been working on the I Am Safe program with Seattle Hubs organization, and they have NTS, the traffic system, RRI, etc., very deeply integrated into their emergency response planning for the Seattle and so forth. If I put my email in here, maybe hook you up with some of the people involved in that too. They might be interested in getting involved in supporting the traffic system as well.
yeah, because we could use more traffic, that's for sure. Region 7, the daytime Region 7 is a voice net that meets twice a day. I don't know about the CW net for Region 7, but I know that there is one, or at least I see a lot of CW traffic that has definitely come in through CW operations. I don't know where it's coming from, but
Right. Yeah, we have a lot of work to do. And I think now that we have a good collegial relationship with the ARRL, I think we're working together kind of, to the same ends. I think you're going to see big improvements in the traffic system.
I hope.
So, any other questions or comments before we close for the night?
I have a question.
Yes, go ahead, John.
If one becomes a digital traffic station, particularly when they're first starting out, I guess one of the scary things for me is that I log on some abnormal day and I get dumped 1,000 messages that I'm expecting to deliver. Is there some way I can say, don't give me more than, X number of messages, or I'm not ready to take messages yet because I'm still learning?
Unfortunately, no. And the reason for that is, you're performing a liaison function. If you connected to Eastern Area Net, Voice Net, and said, I'm representing Region 1, and they said, I have 1,000 messages for Region 1, you would get them. From a practical standpoint, you'll never see that many messages. There just aren't that many at any given time. So I don't think you have to be worried about that. You may pick up, you may pick up 5, you may pick up 10. I just sent 27 today to California. So whoever picks those up in California is going to get 27 messages but they are for the whole state. And if California is broken down by zip code, then the DTS isn't going to get all those. But that's a lot, and that's rare.
Yeah, and that's one way, I guess, Jim, we could probably, while he's getting started, is maybe, have limit it by zip code perhaps a bit.
Yeah, if you were just getting started, as Jim said, we did that. I had a station here in Eastern that was just getting started and said, I only want to take messages from my county. And I said, fine, tell me all the zip codes in your county. And the individual gave me all the zip codes, and that's all we set up for that individual to receive. And anything in his state for any other zip code went to one of the other digital traffic operators. So we clearly can bring a new person on with a restricted set of zip codes.
Thank you.
So, do you know, is it possible to use the zip code sequence with an unreal zip code if you wanted to like maneuver specific types of traffic to some specific recipient?
Um, yes, is the I don't want to give you the wrong answer. That is a really bad idea.
Here's the reason
But yes,
here's the reason
we
I was
are
thinking
actually
of that.
doing that.
Here's the reason I was thinking of that is all this reminded me of old internet stuff, and like, I know there's the volume problem. So if I were going to do it, I'd set up a separate hub. But old software that's still out there like UU encode, you could send a small image file with it. It'll break it up into segments and send it as text, and so it doesn't have the digital problem, and it still sends it. That's not perfect at all, but at least you could send a photo without having to go into level 4 or anything like that.
Yeah, no, you're right. And in fact, Jim mentioned the certified radio operator. We do something very similar to what you're talking about when we're addressing a certified message going through the digital traffic network. If you're sending a certified message to Maine, you would not address it to a zip code. You would address it to CROME at the zip code level. And that says this is going to a certified radio operator in Maine. And that restricts it down to only some of the digital traffic stations in that state.
Right. Cool. Yeah. All right. I'm done.
But that's a hub function, and special routing rules have to be set up.
Right. Yeah. Okay.
So kind of a follow-up to your person who only wanted his county. So you have it set up for him for those zip codes, and all of the other zip codes are available. If someone, say, for covering that whole state were to log in, would they also get the messages that were reserved for those zip codes?
Yes.
Okay.
Unless those other stations are set up to exclude those zip codes, which is not a good idea. I mean, if you have a new person coming on and they're going to cover just a few zip codes, but that person's on vacation for a week, you don't want that zip code range to be stale for a week. So somebody else said, what happens if you pick up a message and can't deal with it? Can you put it back? Technically you can't put it back into the digital traffic network in any easy way, but like anything else, if you pick up a message off a regional or an area net, you can service it back to the originator saying, unable to deliver ARL 67, etc.
Yeah, the same fundamental rules of traffic handling apply, right? If you can't deliver a message, service it back. Invalid phone number, email inoperative, addressee refuses the message, whatever the case might be. There's a process for that, and I think of DTN as a medium, right? It's a medium. But the radiogram ICS 213 is the message, and it has its own specific rules of how messages are handled. It doesn't matter if they come by carrier pigeon or DTN, though those rules are immutable, right? It's not mode dependent.
Jim, could I jump in for a second?
Yeah, you can, Charles. Go ahead.
Okay, I just noticed a message from N0CVL. Now, I didn't want to bring this up in the middle of this, because Jim is talking about the VARA and the WinLink stuff. But N0CVL is asking that if he has an active BBS in his area that he's already pulling messages from, how would it work? Does it make sense for him to go the DTN HF route? I don't know if you want to dig into all this tonight or make this a separate session.
I think we should make that a separate session. I mean, if he's I missed that, Charles, in as the messages were going by, but if he's operating that BBS, that BBS could become a digital traffic network hub for the area. But if it's let's take it offline.
Okay. Yeah. Just as a quick one, guys, if you have questions about BBSs and how they do link in, drop me a note and let's chat a little bit. And then when the two Jims get together and we set up a time for this, we can actively discuss it in detail. My email is n2nov@n2nov.net.
And
I'm also the 44 net coordinator for up here in the Northeast.
And Charles has set up many of the BBS networks to forward traffic into the DTN. We have some hesitancy to forward traffic out of the DTN into a BBS because we lose control over any audit function or any knowledge of whether that BBS is up all 24/7 and how many users there are and so on. We really want to be able to track messages. So incoming messages are welcome from all these other networks, but we want messages to be picked up by digital traffic stations.
Yeah, we do the auditing function here in the New York City station.
Yes.
So we can always teach everybody else how to do that. So that'll start to clear up those issues. But again, that's something we won't dig into right now, but it's something we will carry forward.
Yeah. No, I think that's a good thing to pursue. You have a lot of good information to offer, Charles, and that you can take advantage of. Yeah, David Brandt, AC4JB. Is that an old RCA Amplifuzz behind you in your picture? I don't know if he's going to.
That is a TT50AH RCA television transmitter.
Okay. Okay, gotcha. Yeah. Yeah,
and that picture is from 1981, so I don't look like that anymore, and that transmitter is long gone.
Yeah, I'm sure. Yeah, yeah, I definitely recognize the RCA style there, but it makes sense now. Yeah, look, now you mentioned that it was a TV transmitter. Yeah, I see that. Yeah, that's pretty cool. Good old picture.
It was a great transmitter. It's a shame they don't make them like that anymore.
Yeah, right. No, they don't. No, those days are long gone. Yeah. Okay, any other questions, comments?
I've got one quick question. Do you have to have CW proficiency to be the DTS?
No.
Okay, so if I downloaded a message that needed to be forwarded the final mile in CW, I'd have to return it then. Is that correct? Until I get more proficiency?
Well, yeah, either deliver it directly or, find somebody on your sideband net that is CW capable. No.
Cool.
Or deliver it on a VA. When I lived in New Jersey, we had a lot of people that just put it. We had local 2-meter nets, traffic nets. You just are responsible for delivering it or forwarding it to another station. It's your choice how you do that.
Roger. Well, thanks for that. I'm working on CW, but I wouldn't say I'm proficient enough.
Yeah.
No, it doesn't have to be CW.
No, there's not enough of us CW guys around. If we made CW a requirement, it'd be me and Marcia and maybe a half dozen others probably. So there's a fair number of CW traffic handlers out there, but yeah, you
and there's also keyboard CW using something like FLDigi. There are ways of doing this.
Yeah. There are, but it just doesn't work well for traffic handling. Yeah, we've had people try that on the CW traffic nets, and using the computer and the keyboard, it's just not the same. Yeah, it's
practice.
Yeah,
that's what it all comes down to.
Yeah, absolutely. Well, anything else before we close for the night?
I did type up a quick comment in the section only because I'm fighting a cold and trying to save the voice, but you may want to include that in your slide deck if I am, of course, correct. If I'm incorrect,
okay,
call me out.
So for the Canadian bound traffic?
Yeah, Canadian bound, as well as like the full example of a radiogram and WinLink that includes the break and where you need breaks between, like, to say, the address and the text.
Right. So Canadian traffic is essentially the same as U.S. traffic, except instead of the state, you have the provincial code.
And instead of a 5-digit numeric zip code, you have a 6-character zip code with no space.
Yeah,
it would be the traditional Canadian zip at NTS-NS for Nova Scotia.
Right. Yeah, so just my suggestion was maybe in your slide deck include U.S. and Canada. Right. Use this format, and for international, use the other format. Yep. And then, for the actual radiogram message, and when like you might want to include the BT for break and AR for end of message, if that's the correct way of doing it.
You don't need the AR, but you're correct on the rest.
Okay. All right. Very good.
AR
Thanks.
is optional.
Yeah.
Okay. Very good. Thank you.
So I'm also assuming that in the United States, you're only looking for 5-digit zip codes, not
Correct.
9.
Correct.
Okay.
Yeah, no zip plus 4, just the 5-digit zip code.
Other comments, questions?
I'd just like to say thank you, James, and I'm looking for your YouTube video because I'm sorry I couldn't get here.
That's fine, Marcia. You know pretty much all of this anyway. So.
I think I know, but I get questions from a user standpoint, and I said I've never been a user. I've always been a sysop.
Right, yeah. No, we'll post it soon, so no problem there. So, okay. Well, I guess with that, it's been an hour and 45 minutes, so I think it's time to let all of you go out east. You can all go to bed or watch the evening news or something. And the rest of you, and say the Mountain Time Zone or the Pacific Time Zone, you can go do something else. But thank you everybody for being here tonight, and we're really happy to have everybody here. It was a great turnout, and really appreciate the interest. Have a fine weekend.
Thank you, Jim and Jim. Great presentation.
All right. Thanks, everyone.
Thanks,
Jim. Good to see you.
Yep. See you soon. Yep. Bye-bye.
Thank you.